Okay, so today's lecture will be on how to create user interfaces and desktop user interfaces for using Python. And we're going to use a special module called PyQ5. And there are several modules that do basically the same thing and use the same toolkit, but we are using the PyQ5 module. And so one problem we have in today's environment is that we have a lot of different platforms that we can use for creating user interfaces. So for desktop use, we have a variety of Linux versions. We have Windows desktops and we have Mac OS desktops. And on Linux, we have a toolkit called X11, which is a C library which you can design or create user interfaces with. There is also a newer library called Wayland, which has the similar functionality to kind of wrap the user interface creation. On Windows, we have two libraries. Basically, we have Win32, which is the classical way of programming Windows application. It's a C library, C API. There's also a more modern version called WinRT, which is C++ based, but also Windows only. On Mac, we have, and also to some extent iOS, we have the NS kit for Next Step User Interface Kit and UI kit for both iOS and Mac OS. The problem is that when you want to create applications that run on all these platforms, you need to first create one application that uses the X11 library. You have to create another version for Windows and a third version for Mac OS. Of course, you can share a lot of your own code, your simulation code or your visualization code between these applications, but the user interface has to be written once for every platform. And this is not a very good situation. So to solve this, you add a layer on top of these user interfaces. And one such layer is a toolkit called Qt. It's implemented in C++, and it hides all the details of user interface creation from your own application. So if you write an application against the Qt library, it will, and recompile it for different platforms, it will behave the same way on all platforms. And also you only have to maintain a single code base of your application that instead of 3 versions of your user interface code. And Qt is used in a lot of large commercial applications. It's also used in the Linux desktop project, the KDA project. That project is based on the Qt as an underlying library. And the nice thing with Qt is that when you write an application, the application will behave as it would behave on the platform that you're running it. So if you're running a Qt application on Linux, it will look like a Linux application. Same thing with Windows, it will look like a Windows application. The look and feel are the same. Same thing with running on the Mac OS, for example. So running your application on Mac, for example, the menu will be on top of the screen. Running it on a Windows machine, the menu will be in the window. So it will adapt to the different platform. There are other toolkits that instead of behaving like the native application, they all look the same on every platform. So they use the least common denominator to implement the user interface, and that could look a bit odd if you Windows users will run your application. It doesn't look like a Windows application anymore. So, as this is a Python course, we need a way of doing this in Python as well, and there is a way of doing that. And on top of this Qt C++ library, we provide something called PyQ5. And this is similar to the NumPy extension module in Python. So it provides you with a Python interface to the Qt library. So when you're running a PyQ5 application, the underlying libraries are implemented in C++, and only your user interface interaction code is implemented in Python. So then you can write a single application in Python that can be run on any of the underlying platforms. So Qt is a platform-independent user interface library, as I said before, and it abstracts all the user interface concepts in a single library. So I will say that it's not necessary to call any native functions, but basically you never need to call any of the native API libraries on your platform. You can use, if you only use Qt, Qt can provide you with all the access to the platform that you need in a very neutral way. As I said, it adapts to the current platform. You can also, that's why you currently perhaps not recognize a Qt application, because many of the user interfaces can be styled so that they look very differently. So you give your application your own user interface style. So if you want it to be dark with rounded corners, you can do that. The mechanics of your user interface application, events, and message are handled through something called a signal and slot mechanism. And you can compare that to connectors that you can connect power sockets. So if you have a button, there is a connector, you can connect a cable to the method that you want to perform in your code. So every control that you put on a window can send out signals, and those signals can be connected to slots to receive this signal, and then you can respond in your code in your application. As I said, Qt is a C++ library, and using it requires a binding. So binding is a word that you probably will hear in many Python circumstances. Is that a binding is a connection from a C++ or C library or a Fortran library to Python. So it's a connection between the scripting Python to a native library on your machine. There are actually, unfortunately, several bindings for Qt. So the one we are going to use in this course is called PyQ5. There's also a PyQ4 for the older version of Qt, and there is also an upcoming PyQ6. There's also Qt for Python, which is called PySide, which is basically the same as PyQ5. Most of the classes and names are exactly the same. There is Python Qt, a little bit more obscure version. And as I said, we will be using PyQ5. We will also use something called event-based programming. So up until now, you have been using your programs have started from a certain position in your code. It has been executed, and the program ends when that code finishes. User interface application behave a bit differently. They are centered around something called an event loop. So basically, your application starts, and your program sits in a loop waiting for things to happen. So, for example, what happens is that you get a message from Windows or Mac or Linux that something happened in your window. You press the key, you click the mouse, or other system messages. And that event loop then dispatches the message to the code in your own application that will handle that event. For example, if you open a menu, you perhaps have a code to kind of display something. And the loop will exist as long as the last window in your application has been closed. So usually when you have several windows in your application, you have a single event loop. And when you close the last window, the loop will exit. And in pseudocode, this can look something like this. So this is not the Qt event loop, it's just a pseudocode for event loop. So you have a flag called running is true, and you have a while loop here while I'm running. First thing I do, has anything happened? So I will check for event. And if there is an event called button click, I will call my own method called handle button click event. And then you can have a long list of if statements here to call out to different parts of your code. And you have perhaps also a quit message here. So if the application is quit, you just set the flag to running is false. And then the application will exit this loop and terminate execution. So this is the kind of basic concept of an event-based program. In Qt, typical main program can look something like this. you have from PyQt widgets. So Qt widgets is a module containing all the classes for creating user interfaces. So this is a really good example of object-oriented programming. So the entire Qt library consists of hundreds of classes that you can use to create and implement your user interface. One of the more important classes or objects that we need to create is an application object. And you can see here that we have a Q application here. That is, this class implements the entire functionality of a Qt application. So it kind of connects to the underlying platform, makes sure that everything is connected and you can run. You can also pass along any arguments from the command line here. So import sys, that is a Python library, and argv, that is a list of the arguments to the command line. So we just pass it in here, and the application can have, there are some built-in command line switches that you can use for Qt application that you can pass along here. So now we have an application. To be able to show a user interface, we have to create at least one so-called widget. And a widget is the base control or base class for all the user interface objects in Qt. And if you don't have anything else, if you create a Qt widget, it will create an empty window on the screen. So we create a widget object here from a QWidget class, and then we tell the widget to show itself here, show. And then we enter the application loop, which is called appexec underscore parentheses. Bit odd. Exec was already taken by Python, so that is not. That's why we have an underscore here. So application execute. So that exec method here, that contains the event loop, and it will sit there waiting until the final window closes, and then we call the function sysexit, which terminates the Python application. The sysexit here is not strictly necessary. You can have only the appexec here as well. It's just that appexec will also, if something goes wrong, it will return a return value, which you can pass out to the command line tool as a return value here using the sysexit function. So if we go to here, we can look at how this looks like. This is the code that we have. And if we run this, we get a window here on the screen. And so the Q application and the widget has a lot of built-in functionality for managing a window. So all of these things that you expect from an application is already available here. You can resize, we can maximize, restore, and so that is already implemented here. So that needs no code. And a widget by itself, when it's the only thing in your application, Qt will automatically create a window for you around this widget. So the widget is actually the gray area inside here. That is the widget we created. And you can see here now in the bottom here, the application is running here. So if I exit or click the exit button here, you can see here that it exits the loop here as well. So if we do print statement here, print before event loop, then here prints after event loop. If I run this application now again, it will first say before event loop, and if I close the window here, okay, apparently it exited before. Okay, we can do it like this instead. The sysexit will exit application without continuing. So if you just do like this, you can see it as well after event loop. So the application will exit automatically when the last window has been closed. Okay. So Qt application, the widget is the base class for all the user interface objects, as I said. And the widget can also contain multiple other user interface controls. So you can add buttons, text boxes, checkboxes, and everything to a widget. So it can consist of multiple controls. And as I said, if you only create a widget, it will create a window around it if there is no parent to that widget. You can derive a custom application window from QWidget to kind of control the way that window looks. So usually you do it like this. So this is your customized window. So I create a class here. And as I told you before, a class is a blueprint of the objects you want to create. So if I want to create my window here, this is the kind of blueprint for how that will look. So as I said, this is the constructor, def init. I call my parent constructor here as well. And I usually have a special init GUI function here that I call that contains all my user interface construction code. So by default, there is a method called setGeometry, where you can set the size of your window. There is also a method called setWindowTitle, which will set the title of the window. And then I will show here. And then I, instead of calling a widget here, I can create a new window here, my window here. And I also put the show method here below when you create the window, so it automatically displays. So I don't have to explicitly call window.show here. So how does this look here? So if we go to X2. So this is my complete application here. I have my import statements for Qt widget. So I implement application and widget, init my GUI, and I run. And then I create my window down here, and then I call my application loop. So let's see how this looks. So now you see that the window is now 600 by 600, and I also place it on 300 by 300 XY position on the desktop. So top left corner is always 0, 0 on a desktop, and then 300 is something like here. And then you see also I have a new title here called My Window here. So of course we want to have a bit more functionality in application. So the first thing we have to do is to add some controls to be able to have some interactivity, something to press. And what you do then is you create objects here from the different user interface classes that are built in. So in this case, I want to create a button. The class for a button is called QPushButton. The first parameter is the text of the button, and the second parameter is the parent of that button. So in this case, I want this button to be attached to my window. So I provide self here, which is reference to my own object. I also make sure if I want to interact with the button in my other code, I have to make sure that I attach the button to my own object. So in this case, self.button equals to QPushButton. Then that is attached to my window objects. I can set a tooltip text. That is a text that appears if I hover over the button for a longer time. It displays a hint. I can set the size of the button here, and I can also move it on the screen on the window here. So this is 50 by 50. And that is also referenced on the top left of the core of the window. So let's go to EX3 here. I have my button here, and I just like before. So now you can see here that I have a button here in my window. A bit small, but you can see it. I can press it, but nothing happens here. But it's still, if I hover over, it shows you the tooltip here. So all that functionality already built in. You don't have to code anything of any of this. This is built into the QPushButton control. So this is how it looks like. So all of this is kind of useless if we can't connect these controls to your code. You mean, for example, start a calculation, open a file. All that functionality has to be connected from the user interface control to your own code. And that is handled through something called events or signals. And as I said before, Qt controls, they have a lot of signals they can send out. They can also receive signals you can connect them to one control can connect with a signal to another control, but you can also connect the signal to your own code. So on a push button, there are several signals that you can use. There is clicked, which is when you click a button. So that's a complete click. So when you click a button, it presses down and you release it. That is a full click. So that is what they mean with clicked. There is also a signal called pressed, which is called when the button is held down. So that is a bit different. Then you also have, for example, if you have a Listbox, there is a signal called current row changed. That signal will be emitted every time the user selects a different position in the list. You connect the code using a connect method. So every button has the signal as a property. So in this case here, I have clicked here is the signal. And that signal I connect using the dot connect, and then I just set my method that I want to connect to. And that's it. Now when I click the button, this code will be called automatically. And there is a lot of documentation found for every Qt widget and control on these links here. And I go back to 4 here. So now I want to connect my button here to, I have a method here below called onButtonClicked, which belongs to my window class. So to connect this, I access my button here, and this is the signal that is emitted, clicked, and then I connect its signal to this method here. So running this, I have my button here, and if you look down here, it should print hello every time I click on this button now. So clicking this will automatically call my own code to do something. There is also a lot of methods that you can call to control the widget. So you can set visible, for example. That is if the widget is visible on the screen. You can also check this by calling the isVisible method. You can check if the control is shown on the screen. So that is basically it's transparent and you can't see it. You can also not interact with the control. So when it's not visible, you can't click it. There is also way of disabling and enable controls, and that can be very important. For example, if you want to make sure that the user can't press run until all the prerequisites has been met, you can disable the run control, but it's still active, but it's not. It is indicated that it's disabled on the screen, and that is controlled by set enabled and is enabled. Then you have you can also, for certain controls, there is only one cursor in a desktop application. So and it can only be at one point in the user interface, and that position is called the control with a focus. So the focus control will have the cursor for entering text. And you can control the current focus by using the .setFocus method, and that is available on all controls. You can set fonts, you can set the text. Usually the default text of most controls are set by using the setText method, and you can retrieve it by using the text function. So in this example here, I create 3 push buttons. I call it button 1, button 2, and button 3. I connect button 1 to button 1 clicked. I connect button 2 to button 2 clicked. And if I click the first button here, it will check if button 2 is visible. Then it will set it to visible to false. If it's not visible, it will set it to visible. So by clicking button 1, it will hide and show button 2. And then we have, if we press button 2, it will check if button 3 is enabled. If it's enabled, it will set enabled false, basically disabling the control, and then otherwise it will enable the control. A bit small this now. So if I press this one here, you show this control disappears. I click again, it comes up again. If I press button number 2, it disables the third control here. If I press it again, it will be enabled again. So if you see, it's not possible to click it. It doesn't even respond to when you move the mouse over. It's just basically disabled, but it's still visible. So that is useful. You can also control how the windows look in your window. For example, there are several ways of displaying a window. By default, Qt window default side is something called Qt window. That is a resizable standard window on any platform. Then you can also provide show window in dialog form. Then some of the controls are disabled, and you can't resize the window. There's also a way of displaying a tool window, which has like a toolbar window, which has a bit smaller caption on top. So this is a standard window. You have all the controls on top. It's resizable. If I instead use Qt Dialog, you can see here that now I don't have a maximize button. I also have a help button here. It's still resizable. You can do tool window. Then you get a smaller window caption here and a small X button here to close it. And this will also adapt depending on which platform you're actually using this. So on a Mac, it could look different than on a Linux machine, for example. You can also control the size of the window. For example, if you have an application that you want to show on the entire screen, you can use Qt set window state here to Qt window maximized. This is maximize. So when I start now you see that the window appears on the entire screen instead of as a small window when you start it up. There is also another one. If you want to program an application that takes over the entire screen, including the start menu at the bottom of the screen and the menu on top, you can use something called Qt window full screen. This is a bit dangerous, but then there is no way of actually, all the buttons are disappeared now. So you have a big white window here, and there is also no way of actually closing it by clicking. So then you have to use Alt F4 to close the window.
Excuse me.
Another very important control in desktop application is the menu. And there are several classes implemented in the menu in Qt. The main one is Q menu bar, which provides the actual menu on top of the window. To this menu bar, you attach several Q menus. So basically, each main menu that is in the toolbar or menu is provided by a Q menu class. To these menus, you connect something called a Q action. And a Q action is a way of providing a single event destination for both toolbars and menus. Because toolbars very often have the same functionality as the menus in an application. And you don't want to create redundant event methods or slots that you connect to that where you have to duplicate code. So an action, instead of you connect your code, your own code to the action, and then you add the action to the menu and the toolbar. I will show you this in an example in a minute. As I said, menus are connected to QAction objects, so it's a generic connection in the user interface that is shared by menu toolbars. You can also, in those actions, you can provide icons and shortcuts to handle a certain action in the application in a single location. And you connect events from the actions to your own source code instead of connecting directly from the menus or buttons. So in this case here, I want to create a main menu in my application. So I create an action here. I also say that my action should have a shortcut, that is a keyboard shortcut, Control-T. So when I press Control-T, this action will trigger. And the action has a signal called triggered, which is called when you select it in a menu or in toolbar, which you connect to my own code. Then I create a menu here, and I add a menu called file bar, which I assign to the file menu object here. And then I add an action here, my action, which is my own code here. So here I have a menu, my actions here. I have file menu. So let's see what happens when I run this. And now you see I have a standard Windows menu here. And also in that menu is displayed a shortcut that is available. If I click here, it will show a message box like this. If instead of clicking the menu, I press Control-T, I get the same action here. Basically, it calls the same code. So in this way, you can create a user interface and provide shortcuts for your application for different things. So the user has the ability to use both the keyboard, toolbar, and the menu, but you have only one action and one part of the code that is responding. So in this case, this code here responds to any of these ways of accessing this action. It's also possible to add a toolbar. You do it in a similar way to menu. You self-add toolbar, and then you create a toolbar object, and then you add action to this toolbar. Also, I forgot to say that if you want to have a menu in your application, you can't derive from QWidget. You need to derive from Q main window, because Q main window is a special specialization of a window that has the ability to have a toolbar and a menu. So these methods here that I call here menu bar, those are only available in the Q main window class. So here I create a file menu, I create a toolbar, and I connect both of these to the same action here, which is connected to this method in my class here called onMyAction. So now you can see here I have an application here that has a file menu. I also have a my action here. And the cool thing, without doing any coding at all, I can move around my toolbar. This functionality is already built into the toolbar object, so I don't have to do any coding for this. And if I press here, the same method is called as when I press my action here. Toolbar 2. And here is a bit more complicated example here. You see here I have a new file, open file, save file action. I have an exit action here, and I have a cut, copy, paste, and I create a menu. I add all my actions. I create a menu bar, top menu, and then I create the toolbars, and then I run my application. And now you see here I have a toolbar, or actually two toolbars that I can move around. I have two menus here. And you see here also the icons I have here, those are connected to the action itself. So the toolbar has the action, it uses the icon from the action, and the menu also uses the icon from the action object. And let's see here. And these methods here, these images here are in the same directory as the application here. So it set icon, it loads the icon from this file and assigns that to that action. So up until now, all the controls has been laid out by positioning them exactly using coordinates. So X and Y coordinates. The problem with that is when you resize an application, you are responsible for actually moving these controls in a certain position and making sure that you use the layout of the window in an optimal way. And that can be problematic, especially if you have a lot of controls that you want to be in a certain way and that should move with the window. And as an alternative to absolute positioning, you have something called sizers. And sizers are special widgets that are expert in laying out controls in certain ways. So you can have a sizer that lays them out in vertical or horizontal position in grids. And they know how to handle when the window is resized, they automatically reflow the controls, move them around according to certain rules. So in the first example here, we will use something called a Hbox sizer or a Hbox layout. And that is a special sizer that handles objects in a vertical fashion. So if you add controls to this widget, it will sort them in vertical order, and also make sure that they resize and adapt to the window automatically. So what you do here then is you create the controls just like normal, and then you create the layout manager, and then you add the widgets to this layout manager, and then you, in the main window here, you set the layout to this Hbox, and then all the controls will follow this this layout manager. Let's see here, Hbox sizer. So you see here, I create my buttons, I create my layout, I just add my buttons to this widget, set the layout like that. And now you see here, I have my window here with all my controls. And if I resize my window here, they will also resize automatically towards this window here. There is also a way, it also knows the minimum size of a widget. So each widget has a minimum and maximum size that they can use. So in this case here, there is a minimum size of the button. I can't force it to be smaller than that because the button says, hey, I don't want to get smaller. There's also controls for expanding the control. In this case, there is a maximum expand value, so it can't grow more than a certain height, for example. All those things is handled automatically if you have a size sizer. And you can also do it the other way around. You can use the Hbox layout, so it's horizontal box layout. Works in the same way, but now the controls are sorted in a horizontal way. And here you can also say that it also stops at a certain point because the buttons can't get smaller. There is also built-in attributes about the margins here of each control. They need to have a certain spacing between them. So that's also something, a rule that is built in. And of course, you can combine them in different ways. So you can have a main vertical box, for example, that sorts all the controls vertically. And then you can add a horizontal sizer inside this control. So first you have 4 buttons here, and then you have the rest of buttons in a horizontal box. And also what you can do is, if you don't want the controls to kind of spread out, you can attach a spring, which means that it's a certain kind of control that will expand like a string and push the other controls on top. So this here, you can add us using the stretch command here. So here we first create the controls. We create a vertical box layout, which we add the first 4 controls. We create a horizontal box layout, which we add 5, 6, 7, 8. And then we add, we set the layout, the vertical box, we add a layout Hbox to that one. And that is this part here. And then we set the main vertical box as the main layout of the window here at the bottom here. Now you can see here that we have buttons here that are sized in different ways. And you can see that there is an invisible spring here that pushes these buttons up. If I remove this stretch here and run it again, if I resize it now, okay, we're still on the top. Okay, what's this one? I had 2 springs in this. Now you can see here, if I resize here, these will kind of spread out. The same thing with this one here. So if I add a stretch here among the lower left button, there will be a spring between button 5 and 6. And if I resize it here, you can see here that this spring will expand between 5 and 6, pressing the 3 right button to the right and the other ones to the left. And then same thing, I can add a spring back here to the vertical alignment here as well. And then there's a spring here between that will expand when I resize like this. And I resize it another way around, this spring will increase. There's also another way of laying out, it's called a grid layout. And that is a virtual grid where you can put the controls into. So you can, first of all, you can set a sizing policy for each of the controls here, making sure that the buttons will expand in both directions. Then you add the widgets to the grid layout and you specify a row and a column for the grid. You don't have to set the size of the grid. It will automatically decide the size depending on the maximum row and column you specify. So in this case, there will be 3 columns and 3 rows. Then you can specify also the margins that you want to have between the controls, horizontal, vertical spacing. You can also add stretching here, that certain parts of the grid will stretch, both in column-wise and in row-wise. This was the grid layout. This will look something like this. If I stretch here, you can see that I have added stretching here for the mid rows here, mid columns and the mid rows. They will expand. And this layout can be useful. For example, if you have a view of something you're working on in the middle, you can have the view here and you can have controls that surround this view that automatically resize in different ways when you move the window like this. So that is a grid layout. Let's see here. I think we take a 10-minute break and get back at 2:10, and then we continue with some other interesting user interface controls. Yeah. So let's continue. Next, we're going to through the concept called standard dialogues. For many cases, when you need to do common tasks on different platforms, many of the platforms have built-in user interfaces and windows for this. So it could be, for example, for displaying a small message. It's called message dialog. There's also for displaying messages for opening files and saving files, selecting colors. There are many more of these controls that are available. So it could be a useful idea to check your platform or Qt for if there is a control that or standard dialog that can solve your problem before you implement your own windows with all the controls. So some simple controls are, for example, displaying a message. And that is done by using the Messagebox information method here. So let's see here, Dialogs 1. In this case here, I have a menu bar connected to information box. So if I run this application, I select here, and you see here, this is a message box in Windows. If you run this on a Mac, it will look a bit different. Same thing on Linux, but it's the same method you call. The first parameter here is that you need to be able to, every controls that you have in the Qt needs to be attached to another object, except for the main window. So in this case here, self here means that the message box is connected to my window class or my window object. Then you can have critical as well, that displays something that is really serious problem and displays a red cross on or stop sign, I think something like that. It works in the same way. So the second parameter is the message, and that is the title, and the second one is the message. And you see self here is the owning parent of this control. There is also a warning, but it's a bit less. And you should be a bit careful about displaying these messages. At least the information is kind of a bit nothing that can be used often. But if you do warnings or critical, it's very easy to scare a user that something very very critical has happened. So you should kind of restrain yourself from using these warning and critical. If it's something that the computation has finished, this is not a critical operation, so then you can just do an information box instead of using a critical or warning. There is also a special version, special dialog for asking a question. It's called a question, Messagebox question, and then you can specify here the title and the question, and then you can provide switches here for which controls to be shown. So there should be a yes button, a no button, and which of these should be the default. And then the result from this message box is either a Messagebox yes or Messagebox no. So you can check here the answer from the user. Here you can see I have a tabot, and you see also there is the default control is a bit has a bit thicker border. So if I press enter here, it will click on the no button by default. If I click yes here, it says here you choose yes, and if I click no, no was clicked instead. But that can be, for example, if you want to check, are you really sure you want to create a new project? Then you can ask a question, yes or no. Could we use that? Another important dialog is the file dialogs. So, for example, if you want to ask the user for which file name to open, you can use the Q5 dialog, get open file name. Here you set the title, and then you can set the flow, the default file types that it will recognize. So this will be the kind of which files to display in the list. So in this case, star INP will only list files with the INP extension. And then if it doesn't return or the user cancels the dialog or doesn't select anything, the file name will be empty. So you can check here if the user selected something, file name will be not empty, and it will display the file name here. File open, and you see here on Windows, this is the standard Windows dialog for displaying opening files. I don't think I have any flow input files here, so I don't know what I will just see if I can just start. select the file here, click open, and you can see here that it returns a string with the complete search path to this file. So this is a useful command. And here you can filter out the files that should display. There's also a file save dialog, which does the opposite. It asks you for a file which does not exist or could exist on the disk, but the user can enter a file name, and it will return you the absolute path to that location that the user has selected for the new file. So here I can do a test, save. There is already a test. So this is actually built into the dialog. So this is not something we have to program for. Yes, and you can see here that it creates a file called test here with this absolute search path. So basically, a single line here can provide a lot of functionality for your application. So next part here, I will go through some of the common user interface controls that are available in Qt. By the way, you will get all of this code you will get to be able to download. I have a question here. Yes, everything here I will provide them after the lecture here. So you will also get the source code for all of the examples I've shown here, so you can experiment yourself with the code. So we have seen the Q push button, so we'll not go through that too much. But there are special forms of buttons here called checkboxes or radio buttons. So these are buttons that have a state. So you can compare them to light switches on, off, enable, disabled. A checkbox has a on, off state. A radio button is a special form of checkbox that is provide a state that is shared between several of these buttons. Only one of the radio button in a group can have can be checked. So if you want to have them, you have to group them together. Otherwise, every radio button on your window will have only one checked or not checked. So if you put them in groups, that will solve that problem. So let's start with a checkbox. It's very easy. You create them just like a button here. So with a text here, and you also provide the parent. There is a property called setCheck that will set the state of that. So if it's checked, there will be a tick mark in the control. There is a signal called state change, which you can connect. So when you click this here, it will display that something changed. I click it again, like this. You don't have these kind of controls. You don't have to connect them to signals. One option for doing the dialogues is that you have a button. When you click OK, the code will collect the data from the controls and store them. So you can have them just being displayed on the controls without having the signals connected. So that's a checkbox. The radio buttons created just like the checkboxes here. You can also, there is a click here you can connect to. You can check if they're checked or not. So only one of these can be checked at one time. So in this case, I do radio button 1 set checked. That will mean that the first button is checked. If I do button 2, button 1 will be unchecked, and the button 1 button 1 will be unchecked, and button 2 will be checked. Radio. I have 2 here extra. All you can see here that was with control. And as soon as I click on one, the other one will be the opposite. And if you have multiple of these controls, only one of them can be active at the same time or checked at the same time. Combobox is a multiple selection control text box. You can have a drop-down box where you can select from options, and you can also have a text box with predefined options. So this is usually when you have don't have so much space in your user interface layout, Combobox will is a very compact control. You can also connect the signal current item changed. So when the user selects in this Combobox, this signal will change. Current index method will return the currently selected item. You can create them by using Combobox self. You add items to it. So in this case, I add item alternate 1, 2, 3, 4. So this will be 4 items. And I can set the current index by default to a certain position. And then I can connect the signal current index change to my own method here. So you see here, there's a window drop down here. You have certain options that you can check. You can also query the text. So in this case here, you choose index here. So the method event is called with an index. This is the selected one. Then you can also, the Combobox has a current text item here that is the currently selected text. So you can get direct access to that here as well. There's a slider which can be used to provide fast input for numerical values. You can provide options for range, fixed positions, and scale it in different ways. So here you can create a slider. You can have a vertical slider, which is this one here. You can have a horizontal slider like this. You can set the maximum value, the minimum value, and the current value. There is also a value change signal that you can connect, and then you connect to a method here, and it has a single parameter called value here, which is the current value that has been changed to. Here you see you have 2 sliders here. When I pull them out, you can see it prints out values here every time the slider changes. Okay, Listbox is similar to the Combobox, but it displays all the items in a list. It can be used if you have a large number of options you want to select. You can have a list and you can scroll up and down in that list, and you can also support multiple items in that list box. So Listbox here, created here, it looks like this. You have a scroll box here if the alternatives are too many. I use add item just like the Combobox. You can set current row. There's a current row changed signal you can connect that also provides the current item you selected. And also current item.text is also something you can access. And here you can see I have I can scroll down, up and down here, select things in this list box. Line edit is you will probably use a lot in your code if you want inputs from your user. So this is a small box where a user can enter values, text, anything. You set the value using the set text method, and you can retrieve the value from this control from the text method. Created just like any other control, you set the text to text, and then you can query the text here. In this case, when I click the button here, it displays line edit.text. So this is the one I talked about here. I have to click here to get focus. Then you see that there is a small cursor where you can edit it. And if I press the button here, it will display the text in the control as a string. So you can retrieve the text as a string. So this is the base. If you have a program that requires the use of values, you need to take the string. You have to do some error checking to see if it's actually a value and handle that and convert it to a floating point. Same thing the other way around. If you display the user interface, you need to take your floating point values or integers values and convert them to strings. Set the text to the control, to kind of update the control. So on a bit higher level, when you want to create user interfaces, my philosophy is that it's not mixing user interface code with simulation models or models of anything, because your simulation models should be completely independent of the user interface you create. So, for example, it could be in the future that you want to provide a web-based interface to your simulation models or your codes. Then you don't want that code to be dependent on Qt, for example. So when I do user interface, I usually create a standalone model with a computational model, all the methods that interact with that standalone. No, it doesn't even import any Qt code. And then I have a view that I create for my user friend that displays this model. Sometimes it's also called model view controller concept, that you have a model and then you have a view and a controller that kind of manipulates the model. But the model doesn't know about the user interface. It is just, you communicate without, you have method that you interact with the model. And I also divide up my code in two things. So you have one update controls that takes the data from the model and displays it in the controls. And then I have another method called update model that will take the control values and translate them to the model again. So that is my philosophy when you do this. So the model should be able to read a model from disk, load it from disk, and so on. And it's also able to create a new model. So there's all the functionality should be in the model, but all user interface separately. So for example, this is my model here. It has a number of model values that I want to store and should maintain. It also has a way of outputting the values to the screen. And then I have my user interface controls that are defined either in code or using Designer, which I will show you shortly. And then I have, in my user interface code, I have update controls. So the text edit text sets model text value. And also have, for this is a text string. If I have a value here, I have to convert it to string and assign using the set text. So this will take the model, update the controls. Then I have update model method here that will take the values from the controls and set the model values from these. So this is going the other way around. If you have radio boxes or checkboxes, you need to kind of check if model is 1, then I have to set checked. Another way around, if radio is checked, then I set the model to certain values. So this is a kind of clean separation between model and the user interface. So to illustrate how this could work, I will implement, because I have a mechanics background, a simply supported beam. It looks something like this. I have my computation model here for calculating the moments and the sectional forces and the displacements. And then I want to implement this as a Python model that you can use or reuse. So ideally, I want to create a class that implements this simply supported beam. So this is how I want to use it. So in this case here, I want to create a beam. I want to set some properties here, for example, A and B values, the force, the elastic modulus, moment of inertia. Then I want to be able to display the deflections in certain ways. So here I want to create a loop here over the length of the beam, and I want to display the values here, X, beam, B, beam, and so on. So for certain step size here. So I implement this using, so this is my class. No user interface now. So this is just for implemented the computation model. I store all my attributes here. I use __ here. That means that I hide this from, so the user can't access them directly. I will use properties for providing access to these methods. L is a calculated value from A and B. I have to enable to handle any errors converting to and from strings, from floats to strings. I have a method here called toFloat that will take the new value I want to assign. This could be a string or anything, and then the old value is provided as a second parameter. So if Python can't convert new value, it will fail and return old value. So it will fail silently. It doesn't kind of screw up the existing value if you put in such something that is not wrong. I implement get set methods for all my values here. So in this case, I have every time there is I want to set a value at this floating point, I call this toFloat, and I give the existing attribute as a second parameter. So if everything fails, it will assign A to the old value again. And then I create properties for everything. So A, B, L, P, E, I are properties of this beam. And a nice way with implementing this toFloat is that I can actually pass over all the values as strings. If you look at this one here, it will convert. If this is a string, it will try to convert it to a float and assign V. So all the conversion from strings to float is handled inside a beam simply supported clause. So the user interface doesn't have to do this. I can pass the user interface text methods directly into a simply supported beam clause. And of course, the length here is a computed value. So get L will compute values by adding A and B. So there is no set method for L. And then I have some methods here for computing the deflections here, depending on the X value. And the return, if X is less than A, it will return this. Otherwise, it returns this expression. The section forces, the moments, bending moments, same thing here. So now I have my computational models ready, and I can run this. I have a beam model here. This is the class that I've implemented here. And then I have an example of using it. So if I run this, it will look something like this. It will plot the deflections, the section forces, and the moments like this. So now I want to create an engineering tool here. So I want to provide this to the engineers to be able to calculate this. So I want to create a user interface that looks something like this. I have parameters here, A, B, P, E, and I. And I want to be able to modify these, and this table should be updated automatically. So this is a text box here, which I fill with text. So now I create a separate file here for my user interface. So I create a class beam window that will implement the window for this class, for this user interface. And then I import my beam model here. So this is the only connection. So the beam model will never see any user interface code. This will be connected to the user interface only here. So in this case, in my beam window, I create an instance of my beam object here. And then I have my applet controls and I applet text edit here. I create all my controls like this. And then I connect my events here. So what I do here is there is on all these line edits, there is a special signal called editing finished that will be called whenever the editing in the text box has been completed. It will call editing finished. So this is an overview. So I have applet controls that will set the values of the controls. Here in this case, I call self beam A and I convert it to a string, and I set the control to this text here. Do this for all the parameters. I also have a text edit box that I need to update. That will actually clear the text control it will append all the values to this text control, do the loop here and update, move the cursor to the beginning. And then I have also a method called update model that will go the other way around. So it will assign A here, the value of this. In here, you can see that I assign actually directly a text here. I don't do any conversion because this property A here will automatically handle the text conversion. So I can just, with error handling. So this is the way going from the controls to the model. So now I also have to handle what happens when you edit the text boxes here. So first I update the model. So get the latest values from the controls. And then I update the text edit box to display the latest, the table of values that I want to have. So, and then I will update the controls again to display the new updated values here. So how can this look? So I have a Beam UI model here. So this is the completed application. And if I run it, it will look something like this. Now I have my engineering tool here. It's scalable here. So now this is the plot here. And what I do now, so if I just kind of try to provoke this user interface. So if I put an A here, and I go to the next one here, the editing finished is called here because I left the focus of this one. And you can see here that it replaced the invalid value with the old value. So how much I try here to kind of change it, it will always try to, doesn't display an error message, it just kind of goes back to the default value. But if I do 2.2, you can see here it automatically recalculates the table. If I do 3, you can see here that there is more values here as well. So with this, it automatically calculates. There's no button to calculate here. You could have, instead of having editing finished, to have a separate button to calculate as well. But I like applications that respond directly without pressing anything. So this is one way of doing that. So hopefully this will show you that I have separated the user interface from the model. So the model, if you look at this, it doesn't have any imports at all here. It basically just implements the computational model for this Beam, nothing else. And then you have Beam UI that imports the user interface code here, imports the Beam model here, and this is the connection to the computational model. So the computational model doesn't even know that there is a Qt library talking to the model. So that's a way of separating user interface code from computational code. So now you all think probably that this is very complicated to create user interfaces. Yeah, it is if you're doing it like I showed you now. But this is the way I showed you now is just to kind of be able to learn how to understand how the objects relate to each other. There is another way of creating user interfaces in Qt, and that is by using something called Qt Designer. And Qt Designer is a window or application where you can actually design your user interfaces without writing a single line of code. And the reason for this is that if you have large user interfaces, they can be quite complex, and they can contain hundreds of controls and actions and different ways, and it's very hard to code by hand. And also implementing code, they become very long files. And then that's why it's much easier to implement this in interactively using a special tool. And Qt, user interface in Qt can be described in XML format, and those files are called UI files. And these basically only contains the description of the layout of your user interface. And you can load them from your own code to create a window, create the controls and all the layout, the sizers, and so on. And you can create those using the Qt Designer. And to be able to use these files in your own application, you add another import statement called PyQ5 import UIC, and that stands for UI compiler. So this is a compiler that reads the user interface files and generates all the code, all the objects that you need. So you don't have to create any object. That will handle by this load UI method here. So load UI, and then I specify which file to load the user interface file from. Then I specify where these objects should be created in. So in this case, I want all the objects to be attached to my main window. So I put self here. And the names that you give in the Qt Designer will also be the names of the objects here that you call. So in this case, in this form here, there is a push button that is called like this. And all these objects will be created with the names that you give in Qt Designer. So now I'm going to try to demo this. This is hopefully I will be able to do this live without Qt Designer crashing. So when you start up Qt Designer, you get something like this. It starts up asking you for what kind of user you want to create. So you can create a dialog with buttons right, left, dialog with buttons, main window. That is if you create a main window with a menu and toolbars. Widget is if you want to create a completely empty user interface that shouldn't have a menu, for example. So just to make it easy, I will do a simple one here. I will create, and then you get an empty window here. That is your actual user interface. And what you can do then is that usually when I design the user interface, I drag my controls from the left side here, which shows you all the controls that are available in Qt. And you drag them over. So for example, I can drag a button here, drag another button, and like this. And then I want to have on my right side of my control, I want also to have 4 buttons like this. It's enough to just kind of roughly put them in the right positions. And below here, I will also want some buttons here. Like this. And in the middle, I want a text editor. So I will create a line edit control here, a text edit control here. Drag it out like this. So these 4 buttons I would like to group together. So then I just select this one here, and I say that I want to arrange them vertically. So I click this button here, and now you see that it's arranged. It's a sizer that sizes them in vertical orientation. Same thing with these ones here. They should also be arranged vertically. These ones here should be arranged horizontally. So I press this button instead. Now I also want to arrange on a global. So if you see here now, it doesn't resize very, very nicely. So I want to divide this user interface into 3 columns here. Oh, sorry, 3 columns here. These 3 here should be 3 columns. Then I just select them like this. And I say that I want to have them laid out horizontally like this. And I want this entire thing here to be 1 row of the user interface, and this should be the 2nd row. So then I can mark all of these here, or let's say, so the main layout of the user interface of the window should be vertically. So I select the main window like this, and I just click on that one. Now you can see here that it maximizes the layout of the window is vertical. Then I have several controls in different hierarchies like this. And if you look up here, there is Object Inspector here that displays the actual object hierarchy that you have created. So you can see on top here, there is a Q widget. That is my main window. I have a horizontal layout, which is this one here. And inside that horizontal, I have 2 vertical layouts, which is these buttons here. And then I have a horizontal layout below here. So what I want to do now as well, I want to make sure that my buttons are kind of on the top here. So I want to add a spring like we did before. And you can see here you have two controls here called spacers. I can drag a vertical spacer now over to in this control here, make sure that this line is blue here, and you just release it. And then you can see here that there's a spring that expands and pushes this button on the top. I do the same thing on the other side here, and then I release. And then I want these buttons to be centered in the middle. So I take horizontal spacers here and I try to put them inside here. And then I put one on the other side here. Like that. And now I want this push button should be the button I have in my, I have a, let's see, a form. This should be called press me button here. So now I need to set this, the name here. You can see here that I have all these controls are given the names by default, and these will also be the names that you will have in your code. So a tip here is that make sure that you name all the buttons in your code in a good way so you can identify them easily in code. So let's see here, if I go down, this button is selected here. Below here you have something called a property editor that displays the properties of your selected button, in this case the push button here. And you see here that it's called push button 10. And I changed the name to press the button. I also want to change the text in this one here. So you can go down here. The yellow here, that is the properties of the derived class QWidget. So this is our inherited properties that are equal for all objects in Qt. If you go down, you can see here that abstract button is the next class it inherits from. And there is also push button that is the kind of final implementation with its specialization. But in this case, the text properties is shown push button here, and I change this to press me like this. Press enter. Now I set this property here like this. Next step here, I need to save this layout. It says untitled here. Save as. Now a lot of forms here. I do a form 8. Save. And then I go in here and then I change here to form 8 to make sure I load that form to my user interface. Hopefully, if everything works now, we should get the same user interface that I created. And you see here, I have my button here. And if I press that one, nothing happened. To check the name here, let's see if I copy this one here. It worked. It's just that it didn't display. It is properly display. Exactly. So if I click here, it says hello button press down here. So this button here, you get this object automatically created for you. You don't have to do any creation. It's always built in. And you can see here also that it's resizable here in a nice way. So this way you can create really complex user interfaces here. You can set all the properties and you disconnect the user interface description with the user interface code. So this is also a way of separating, instead of having all your user interface defined in code, you have it in an XML file separately from your source code. There are some other ways as well that you can figure out, you can read about on your documentation. You can actually generate, instead of having a UI file, there is a standalone compiler that can create a separate class that you can inherit from with the user interface built in. Then you don't have to provide a UI file with your application. It's kind of compiled to a Python file instead and loaded from when you import the class. You instantiate the class, the user interface automatically created for you. And you can see here there's a lot of different controls that you can use. Spinners, text editors, sliders in different ways, labels, calendars. You can even do OpenGL for graphics. There's a Q web engine view to view web pages. So there's there's a lot of nice controls that you can use. So I will make sure that you have all that source code available so that you can try out. You can download, and I will also make sure that you have the PowerPoint presentation on the Canvas site. And also on Friday, there will be a short recap of object orientation again. So we'll see you then. So thank you for this lecture here. So I will just.
Sorry.